we are going to start going over all of our gas laws or our equations. There are probably 6 equations in this unit. I don't have to count, there might be 7 that you're going to have to know how to use. You won't have to memorize any of the formulas, but you will have to know the names and when to use the correct equation. Honestly, this is going to be mostly algebra and reading word problems. If you can read the word problem, figure out what variables you have, you can figure out which equation to use and apply it. And so most people going through these they struggle with reading the word problem and identifying what equation they need to use. And so I have some hints on how I do these problems and set them up that I'll go through that make that easier so that gas laws are super easy for you. So the first law we're going to go over is Dalton's law. So John Dalton, he did a lot of research with the model of the atom. He also did research with gases, and he found that the total pressure of a mixture of gases, so if you have, like, let's say the air, it's carbon dioxide, it's oxygen, it's nitrogen, etc., etc. So the total pressure of the air equals the sum of the partial pressures of the individual gases. And this is his equation. And so in normal people terms, let's say air is made up of mostly nitrogen, oxygen, carbon dioxide. So the total pressure of the air would equal the pressure of the oxygen plus the pressure of the carbon dioxide plus the pressure of the nitrogen, so forth and so forth. So this ... means that this can continue for however many gases there are. You just add up the individual pressures to get the total pressure of that mixture of gases. Okay. Our first example is this one. So a canister contains nitrogen gas that has a pressure of 1.3 atm, carbon dioxide with a pressure of 1.5, that should say atm, not atom, and oxygen with a pressure of 0.7 atm. What is the total pressure? So our pressure of nitrogen is 1.3 atm, our pressure of CO2 is 1.5 atm, and the pressure of O2 is 0.7 atm. And so to find the total pressure, it's P total equals the pressure of all the gases added together. Now, you want to check and make sure that all of your gases are in the same unit, which they are, atm, 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 because you can't add pressures in different units together. So P total equals 1.3 plus 1.5 plus 0.7, and that is 3.5 atm would be our total pressure. Easy enough? I hope so. We're going to do 2 more examples. So this one, a tank of oxygen gas and nitrogen gas has a total pressure of 1.8 atm. So I like to list my variables off to the side, like you saw me do with the last problem. So total pressure, so P tot means total pressure. The little subscript tells you like what your substance is or whatever, so tot total. That's 1.8 atm. And then the pressure of the nitrogen gas is 745 millimeters of mercury. And what is the pressure of the oxygen gas is what we're looking for. Now, these pressures are not in the same unit, as you can see, so you have to convert one of them to the other one. I don't like to use pressure in millimeters of mercury because the numbers are really big. ATM is what I always suggest that you write it in. Smaller numbers, and it's just easier to do. So that is my suggestion. Now hopefully you remember your conversions, and that's 760 millimeters of mercury equals 1 ATM. We'll convert this, divide it by 760 to give us ATM, and that is make sure whenever you convert a unit that you don't have to write every decimal, but it's 0.98026, so 0.98 ATM. Don't just write like one significant figure because that'll throw your number off. And then we're trying to find the pressure of the oxygen gas. The equation for Dalton's law is total pressure equals the pressure of the gases added up together. I know my total pressure is 1.8. My pressure of my nitrogen is 0.98. I don't know my pressure of my oxygen. And so from here, how do I solve for pressure of oxygen? Subtract 0.98 on both sides. And my pressure of my O2 equals 0.82 ATM. And there's one more example. You have one like this in your practice packet, and I do like this one. Okay. A furnace is composed of many gases, and it has a total pressure of 2.4 ATM. 40% of the partial pressure is from carbon dioxide. What is the partial pressure of carbon dioxide? So to figure this out, I'm going to actually give you an analogy. Let's say you have $1 million, but 50% of it you owe, I don't know, like to debt. How much do you owe to debt? Like, I don't know, stocks or whoever you have to pay. The answer would be 500,000. Whenever you have percents and the numbers are added up, all you have to do to get the pressure of just the oxygen is multiply the total pressure times, because it's 40%, by 0.40, and that will give you the partial pressure of oxygen. Total times the percent. That works when numbers get added together. And when I multiply those, it's 0.96 ATM would be the pressure of CO2. It works the same like with money. If you owe someone 50% of your net worth and you're worth $1 million, well, 1 million times 0.5 is 500,000. So when things get added together and you have a percent, you just multiply the percent by the total, and that will tell you how much that one is. So you're going to take 15 minutes and work through page 3 of your practice packet. It's the Dalton's law. They should be pretty easy. And then check the key with Miss Nagley when you're done.